Hello, everyone. Welcome to Kubernetes Data Management YouTube channel. Today, I'm going to walk you through how to migrate containers from a VMware Tanzu to Red Hat OpenShift in about 3 minutes. Yeah, but basically, it is for a small application. Let's get started. So previously, I recorded multiple videos about how to easily to migrate the containers. Could be from on-premises to the cloud, or could be between two different OpenShift cluster, could be across two different cloud. Today's focus, we're going to do from VMware Tanzu to Red Hat OpenShift. That's the one from the bottom. So here is a lab preparation tasks. Basically, you need two steps. First of all, you need to build a Tanzu Kubernetes cluster, plus install the tool, Casting K10. That's the #1 Kubernetes backup DR app mobility tool from your source cluster. If you don't have a VMware Tanzu cluster, you can follow the link here to build one from your web console. After you have a Tanzu Kubernetes cluster up running, you can enable the container backups in about 3 minutes. That's the second link here, a backup containers on TKC. And the whole automation code is available from the GitHub page. Secondly, you need to build a target Kubernetes cluster. In this case, it's OpenShift. We also need to install Casting K10. That's the tool for you to move the containers from a VMware Tanzu to OpenShift. If you don't have an OpenShift cluster here, you can follow the link here to create an OpenShift cluster first. And after that, you can enable the container backups in about 3 minutes. Automation code also listed here. One very important thing to highlight, you do need a common S3 bucket. For you, both source and target cluster can access the common storage bucket. So here is a diagram to show you high level how it looks like and how it works. On the left-hand side, you got a VMware Tanzu up running. It can be two different versions. So in this case, I was using 1.20 running from a VMware Tanzu. And from here, you can see Casting K10 needs to be installed in every one of your Kubernetes cluster in order to be able to protect the containers, to migrate the containers. And in addition to Casting K10, you also have a PostgreSQL database running, including all of these Kubernetes configurations or objects. And obviously, you have the persistent volume claim data running from a vSphere CSI. So when we take a snapshot, do the backup, we basically take a snapshot of your application. So in this case, your PostgreSQL application and your Kubernetes configuration, and plus the data, which is typically the persistent volume claim. So once we take the snapshot, we allow it to copy the snapshot to the external object storage. By the way, it will be a lot safe, more reliable, not to mention you can leverage the cheaper cloud storage for long-term retention. And plus, you can enable the object lock to avoid a ransomware attack. So once you have the data sitting from the object storage, now on the right-hand side, you can see I got OpenShift container platform here. It was running 1.23. I also have a Casting K10 deployed to a separate namespace, but I don't have the PostgreSQL database yet. So now what we can do is I do an import. I will read the data from the object storage. And after the data has been read, and we will do the restore. Once the restore finish, you will see the PostgreSQL database, including all the different Kubernetes configurations, migrated to the target cluster. So typically for smaller application, you only need about 3 minutes. So this is just a diagram to show you how it works. High level, I will do a live demo to show you how it works. Basically, two high-level steps. First of all, from your source cluster, you configure one policy. Part of the policy, we will do the backup, do the export, basically copy to the object storage. And I was using an object storage bucket here, K10 migration for Yong1. And once you create the policy, we will do a backup, do the export to Amazon S3. In this case, I was using Amazon S3, but it can be any other cloud object storage or on-premise S3, or could be NFS storage as well. And once the backup job finish, export job finish from the target cluster, that's the second step. So basically, I create another policy. This time, it's not a backup, it's import. Once the import finish, we will automatically do the restore. And once the restore finish, basically the application PostgreSQL will be up running from OpenShift in about 3 minutes. So, easy. Let's jump to the console. I will show you. So first of all, let's log into the source cluster. As you can see from the terminal, I did the get node state. You can see it is running 1.20 from a VMware. And I have one control plane master node and 2 worker nodes. And second command, which I did is the storage class from a VMware, from a Tanzu Kubernetes cluster. By the way, we are running, TKGS. So that's a vSphere with Tanzu. We're using management storage policy thing, CSI, that's a vSphere CSI. Okay, and if I do get namespace, you can see I got the yum-PostgreSQL namespace. My application, my database, all the related configuration running from all this particular namespace. I will migrate this application to the target cluster. So just to show you from the vSphere web console here, just to highlight, this is built from our VMware Tanzu. That's why you can see here is my workload cluster. I got one control plane node, 2 worker nodes. It is running 1.20. Okay, I got a custom K10 has been installed, and I don't have the backup policy yet. I will show you the backup policy, how to create a backup policy, how to create the location profile, Amazon S3 bucket shortly. So from my target cluster, let me switch the window here. So from the terminal, by the way, I was using AWS Cloud Shell as my jump host. And then from there, I access my Bastion host. Okay, so from here, this is my OpenShift cluster. You can see I got a one node cluster. It is running 1.23.5. So, but yeah, this is one node cluster. It is very powerful. It is a bare metal machine. Actually, I got a 72 CPU and 192 gigabytes memory. And the second command you can see, I got a storage class GP2 CSI. That's my default storage class. So we're going to move from the management thing from a VMware to this GP2 CSI storage class. And the third command here is OC get namespace grep yum. So you can see I get nothing. I don't have this particular namespace. And this one also can be confirmed from our OpenShift Web Console. If I log into OpenShift Web Console, you can see I got a cluster running here. It is a 4.10. That's equivalent to 1.23. And if I go back to the project, if I search yum, that's the namespace. I can't find the namespace. That means I don't have the this particular application running from my target cluster yet. I also have custom K10 here. It is dark background. From here, from our web console, you can see I got 62 applications. If I do the search yum, I can't find this application. So shortly after the migration, you will see the application PostgreSQL will be up running from my target cluster. So let me come back to my source cluster. From here, what we need to do is, first of all, I need to create a location profile to point into the Amazon S3, but it can be used other object storage. Let's say I'm going to create a new profile, give a name, let's say my AWS 3. And you choose Amazon S3 or Google Cloud Storage, Azure Storage, S3 compatible, or NFS or VBR, Veeam Backup Server. So for this case, I was using Amazon S3. You need to provide an access key, secret key, your region, your bucket name, okay? And once you provide all these details, you click Save Profile. We will create the location profile. So for now, I don't want to expose my access key, secret key. So it can be fully automated. So what I'm going to do is I just run a command. we will create the location profile. Okay, everything we do from the custom web console, every click is an API call. So I'm going to run this command. We're going to create the location profile. And once this finish, if I do a refresh, you can see my location profile has been created successfully. So for now, I was using US East 2 region, and this is my bucket name. So this is from my source cluster. I already have the source location profile created. Now I'm going to show you how to create a backup policy. So from my source cluster, if I click applications here, you can see I got a Yum PostgreSQL. It is here. I don't have a backup policy. I just go ahead, create a policy. So you will be asked to provide a policy name. You can change it to a different name if you want. In this location action, that's a snapshot. You can make it every hour, or you can even make it every 5 minutes if you want. And most importantly, you need to enable the backup via snapshot export. That's where you can select the object storage location. So once the snapshot has been taken, we're going to copy it to the object storage location profile. In this case, my AWS 3-migration. And here is the snapshot retention settings. We do give you some recommendations, but you can customize based on your retention settings. So once you've done all of this, you just click create a policy. Again, I just want to show you how it can be fully automated. So I'm going to cancel this. So before I cancel that, just to show you, actually from the UI, we do generate the YAML file for you. If you want to create it from the command line, you just save the YAML file, and then you run kubectl apply or create -f to create the policy. So I'm going to cancel here. What I'm going to do is I will come back to the terminal. I'm going to run a command tkc to OCP migration. So press enter. So by the way, this is just a YAML file. We're going to create the backup policy. Once the policy has been created, we are going to kick off the on-demand backup jobs. So now if I come back to the dashboard, do a refresh. So here we go. We got the policy has been created. So for the testing purpose, I don't want to keep longer. I only keep a 4 hourly snapshot, 1 daily snapshot, 1 weekly snapshot. Here is my object storage location profile. Okay. So if you want to kick off a manual job, you can click run once. But since I automated from the command line, it has already been kicked off the job. Back to the dashboard, you can see the backup jobs has been running. So now we need to wait the job finish. But while we are waiting for the backup job finish, for the export to the object storage finish, I'm going to jump to the target cluster. So what we need to do, first step, we also need to create a location profile and pointing to the same storage bucket. So how to create this? You can create it from a UI. I want to automate the whole process. I just run another command. So migration S3 location. By the way, all of these automation scripts are available from my GitHub page. I will show you shortly. So here you go. We already created the location profile. If I come back to the dashboard from our custom web console, do a refresh. So you can see my location profile has been created successfully. You can see the bucket name is exactly the same from my compared to my source cluster. So that's why shortly, once the job finished from the backup from the export, we will do the import from this particular target cluster. We will read the data from this bucket name. Okay. So let's wait the job finish. While we are waiting, let me show you my GitHub page. So if you go to the GitHub page, and you can see I created automation for all different Kubernetes distributions, including Google Kubernetes Engine, Azure Kubernetes Service, Amazon EKS, OpenShift is one of my favorite one, and also Alibaba Cloud ACK, even Rancher Kubernetes Engine. So here is a one OCP K10. So it depends on where you're running your OpenShift cluster. You can run it from any one of the public cloud. You can run it from on premises. For this case, I was running my OpenShift cluster from AWS. It's not a ROSA, it's the self-managed OpenShift cluster on AWS. So I'm going to use this one, OCP-AWS-K10. So all of my automation scripts are here. So this is from my target cluster running on OpenShift. Okay, you can see the command which I did earlier, migration S3. These are the, basically just a few YAML files, how to create the object storage location profile from my target cluster. And also you have the, automation command, how to enable the container backups, the K10-deploy to enable the container backups on OpenShift cluster. Typically you only need like 3 minutes. So I got the instructions also listed here. If you're interested, feel free to look into it. So here's the instructions. You basically clone the repository, which I already did. You create, you prepare the environment. Basically, you run OCP-AWS-prep. And then you can build the lab, how to enable the container backups, 3 minutes to enable K10-deploy. So we will install the custom K10 software, deploy PostgreSQL sample database, and also create the Amazon S3 location profile, create a backup policy, run the on-demand backup jobs. All of these are done automatically, typically in about 3 minutes. Okay, once you've done your testing, you can destroy K10-destroy. So I also have a few videos to show you how to enable the container backups on ROSA cluster. You have basically 3 minutes. How to migrate the containers from one OpenShift to another OpenShift. It can be the two different versions. It can be from a higher to the lower or lower to the higher version. Yeah, if you find this is useful, yeah, feel free to follow me. And if really, if you find it is useful, please you can click the star icon here. Okay. The other one I haven't showed you here is for the Tanzu. I also have the automation TKG-K10. Yeah, basically a similar kind of the scripts. You run K10-deploy, you enable container backups on VMware Tanzu in about 3 minutes. So migration S3 location, that's the one I just did earlier. We created the location profile. The TKC to OCP PostgreSQL-policy.sh, that's the command. We're going to create the backup policy. We're going to kick off the job automatically and also point into the object storage. So by now, the job should finish. Let me confirm. So come back to my source cluster. You can see my policy run completed successfully. If I check the job details, you can see the first subtask, we're going to do the backup. So basically take a snapshot of all of your Kubernetes application configuration and your data. If you click the job details, you can see on the right-hand side, you can see all of your spec artifacts here. Maybe somebody accidentally deleted the secrets or configure maps or rule binding service account. Any one of the objects is missing. It will cause some issues. So with this visibility, actually custom K10 does allow you to granularly recover the individual resource. So for now, let me close this one. The second subtask also complete successful. That's the one we're going to copy to the object storage. That will allow us to import from a different Kubernetes cluster. In this case, I will do the migration to OpenShift. Okay, since we confirmed the migration, the backup job was successful, the export job are also successful. Now I need to come back to my target cluster. So we are going to, this is my target cluster, the Docker background. So I'm going to create an import policy. By the way, if I come back to the dashboard, 62 applications here. If I do search, nothing here. So now I'm going to create the import policy from here. So the import policy, import PostgreSQL. This time, the action type, it's not a snapshot. We will do the import. And you will be asked to provide the token to be able to read the data. Where to get the token? It is from the source cluster. from the backup policy. Come back to the dashboard, click the policy, and then towards the bottom of the screen, you can see show import details. I click show import details, copy it to clipboard, and then come back to the target cluster, paste the token here. Now we discovered the location profile, my AWS S3 migration. Okay, by doing this, we only allow you to read the data. But what about my application? I want my application up running. So that's where we can enable restore after import. So once you tick this option, after they read the data from the S3 bucket, we will also bring up the PostgreSQL database from my target cluster. Very importantly, you need to apply the transformation, because from my source cluster, I was using, let me just confirm again, from my source cluster, my storage, object storage here, let me scroll up a little bit. So my storage class is called management dash storage dash policy dash thing. From my target cluster, if I come back to the Cloud Shell, just to confirm here, my storage class is GP2-CSI. You need to transform the storage class. Otherwise, it will say, oh, the storage class cannot be found. So let me add a transformation here. So what I need to transform here is, I just need to transform the storage class, change the storage class to what? To the GP2-CSI. Yeah, that's all I need to do. Once I create the transformation, part of the restore, when I do the restore, I will, instead of using my source cluster, the storage class, I will use the new storage class from my target cluster. And the other thing I want to point it out is, actually, you can import on demand. That means you just want to do one-time migration. So you want to do one-time migration from a Tanzu to OpenShift. You might want to choose on demand, but for some other case, you might want to use a different cluster could be from a cloud, or could be from a different cloud. You can make it actually, scheduled. You can make the say, I want to do the import, do the restore every hour. You can also make it every 5 minutes, every 10 minutes. It depends on your requirements. So for now, I'm going to just to show you how to do the one-time migration. So I choose on demand. Once I confirm this, so again, there is a YAML button here. If you want to make it fully automated, you can, click the YAML, which generates the YAML file for you. You just run the kube control from a command line. You can create the policy. Okay, for now, let me cancel this. I'm going to create the policy. And once the policy is created, so remember, we choose on demand. So it's not going to run automatically unless you choose to schedule the job to run hourly, daily, or, every 10 minutes. So now what we can do is I can click run once. We will immediately to kick off the import job. After the import finish, we will do the restore. Okay, before I confirm run the policy, I'm going to watch the status from the command line. Let's say OC get port. I will watch the status of the recovery. I mean the import migration. Okay, so I'm watching the status here. And then I'm going to confirm run the policy. So you can click, go back to the dashboard. You can see my job will be kicked off shortly. So the policy is running, import PostgreSQL. The first subtask we're going to do is import. After the import finish, we will do the restore job. So while we're talking here, you can see the import restore points has been completed successfully. So if you go to the command line, you can see these are pods contain temporary containers we're running. So by the way, custom K10, all of the services containers are running in the namespace custom-io. So part of the import job, we actually launched the temporary containers data mover to read the data. Once the data read finish, we will do the migration. We will do the restore. So very importantly, OpenShift actually do have the very secure environment. It will not allow you to recover, to bring up the containers unless you need to override the security settings to say, I want to, let me get to the details. So basically, you need to run a command to add the SCC to the user to allow any user ID to run the namespace. Let me run this command. So I'll paste the command OCADM policy. Once this is finished, let me come back to monitor the job. So let's see how it goes. Okay, so shortly you can see, so it was pending initially. So Yon-PostgreSQL, that's the application I want to recover to my target cluster. And shortly it becomes a container creating. And just, typically just within seconds, it will becomes up running. And once it is up running, we will do the readiness check. Once we pass the readiness check, it will be completely showing running and also ready. Okay, so while we're waiting, actually it's already up running. You can see not only running and also pass the readiness check. If you want to come back to the dashboard to confirm, you can see the second job shortly will be marked successful as well. So right now, you can see the job finishes successfully. Total time, it's 2 minutes, 46 seconds. And by the time we recovered the application, you can see now I got 63 application. It was only 62 previously. So click the applications, do another search Yon, you can see my application has been up running. Okay, if you want to monitor, confirm from our OpenShift Web Console, you can select the workload, click the ports, and select the project Yon-PostgreSQL. You can see my PostgreSQL database is up running from my target cluster. In this case, was running from OpenShift. So again, just to highlight, we are moving the PostgreSQL application from a 1.20 running on VMware Tanzu. Now it is up running from an OpenShift container platform. Now it is running 1.23. You don't have to go the upgrade from a 1.20 to 1.21, then to 1.22 before go to 1.23. We have the powerful transformation engine. We allow you easily to do the migration from a lower version to the newer. You can skip the versions. If you find something is wrong, you can actually downgrade to the lower versions as well. So this is very useful. Not only we allow you to use the way to do one-time migration from one cluster to the other, you can use this method to do the standby DR. You can use the same way to simplify the upgrade migration. So most of the people probably are aware that OpenShift, the Kubernetes keeps upgrading, keeps introducing newer versions every, roughly about every 4 months. So we only maintain the latest 3 versions. That's why customer keep upgrading and do the in-place upgrade. Most likely there are a lot of challenges. It is very painful. So with this way, let me come back to my slide deck here. So you can see, I come back here 1 second. So you use this way, you just do the backup from your source cluster and then do the restore from the newer cluster. You can spin up a newer cluster and then do the, import, do the restore, rather than you do the in-place upgrade. There are a lot of challenges. And from 1.20 to 1.23, there are a lot of API changes. And most likely your existing YAML file working perfectly for 1.20, and then you do the in-place upgrade to 1.23, you realize a lot of stuff stop working because some of the API deprecated and then introduce some new APIs. So with Cast and K10, we will mask all of these API changes, all these complexity. We understand the API changes from different versions. So we allow you to make sure once you restore to the new cluster, it will be successful. Okay, let me That's about the demo. Yes. Basically, 3 minutes, we migrated the PostgreSQL from our VMware Tanzu to OpenShift cluster. So here, just to highlight the typical use case for the application mobility or portability. So to simplify your upgrade, cluster upgrade, to easily to allow you to migrate from one cluster to the other. So I only talk about to transform the storage class from a source cluster to the target cluster. Literally, you can transform any one of the Kubernetes objects. You might want to increase the PVC size. You might forget to add the labels from your source cluster application. Part of the restore, we will increase your PVC size. We will add the labels. We will change the labels, change your image registry to match the target cluster. Okay, so also allow you to easily to move the application from the test environment to the production, or maybe vice versa. Just to including you a few reference links, all of the automation code for both OpenShift cluster and also VMware Tanzu are available from publicly from our GitHub page in a custom official documentation page. The third one is Kubernetes free trainings. After you complete all the free training, you can collect all of these cool, Kubernetes badges. I love it. And the bottom two are Kubernetes user group. If anyone interested, feel free to join the Kubernetes user group. And the bottom one is the Kubernetes data management LinkedIn group. Also, more than welcome anyone to join us. Okay, yeah, a few additional links. If you want to learn Kubernetes, I automated the Kubernetes cluster creation and also backup for majority of the popular Kubernetes distributions. Google Kubernetes Engine, Azure AKS, Amazon EKS, OpenShift, Alibaba Cloud ACK, and Azure Red Hat OpenShift ARO. So you can see here are different links to the YouTube video. Yeah, that's all I want to cover for today. I hope it is useful to you. Just a reminder, if you find it is useful to you, please like the video and share it to your friends. And please feel free to connect me via any one of the ways listed here. Thanks for watching. I hope you enjoy it. Enjoy your day. Thank you. Bye.